Example 3 says we have hyperbola centered at 0, 0 with asymptotes of slope plus minus 2 over 3. So I've drawn over here the asymptotes of slope 2 over 3, kind of just approximated that. It does give me a coordinate of 7.5 and 3, which I've kind of estimated here, and I'll get back to that in a second. And we have this setup where we know that the hyperbola is going to be centered at 0, 0, so it's just going to be an x squared over a squared minus y squared over b squared, and we don't know if it's plus or minus 1. Okay, so a couple of things that we have. The first thing we should establish then is there's this slope relationship that is related to a and b. Now, it's important to recognize, and this is really important to know that although this is the slope ratio is b over a, and that's equal to 2 over 3, it's a ratio. So we don't know that a is equal to a is equal to 3 and b is equal to 2. We can't say that because b could be 4 and a could be 6, b could be 10 and a could be 15, as long as they're in that ratio, okay? So we need to just make sure that we don't say that b equals 2 and a equals 3. Another way that this could be done, and this is an alternative way which we will take a look at, is we could put a factor of k and say that the slope is 2k over 3k, and b and a are equal to 2k over 3k like this, and then we can actually come up with an equation to solve for k. So we'll look at that later, but the first thing we're going to do is establish that the b over a relationship is 2 over 3, and that's a ratio, not b equals 2 and a equals 3. And then we're going to relate it to this equation, and we have to establish then if it's plus 1 trans x or minus 1, which means trans y. And to do that, we can look at where the point is located. It's located here at 7.5 and 3. Now, this is an easy one because the ratio of the slope is 2 to 3, and this ratio of 3 to 7.5, well, that's much lower ratio than 2 to 3, so we know that it must end up below in that part. If it's close, we do have to test it against this line, this yellow line, which is the linear equation of y equals 2 over 3x. And then we have to establish whether it's above that line or below that line. But clearly this one is below the line, which means the only way we can draw our hyperbola is to draw it as a trans x hyperbola. It can only be drawn like that. There's no way that it can pass through that point and be drawn as a trans y. So once I've decided that, I can see clearly that this is a trans x, so I must choose the plus 1. Okay, once I've done that, I need to then use the xy coordinate of 7.5 and 3 to plug in, but I still have two variables, a and b. To get rid of one of the variables, we're going to use this relationship of 2 over 3 equals b over a, and we're going to say that, rearrange that equation, and say that 2a over 3 is equal to b. So I just cross multiplied that a, and now I can replace the b with an expression for a. So now my equation looks like this: x squared over a squared minus y squared over, now I replace the b with 2a over 3. So I square that, I get 4a squared in the denominator. That divide by 3 in the denominator ends up in the numerator as 3 squared. So we get 9y squared like that. And that's going to be equal to positive 1. Okay, I have to choose, I can't have plus minus, it has to be plus 1. Now solving this then, solving for a, I'm going to substitute in my x is 7.5. Okay, that comes from my point there. And I'm solving for a, so I'm going to have a squared minus 9. the y is equal to 3, so I'm going to do 3 squared, all over 4a squared, that's equal to 1. To solve for a, I need to get a out of the denominator, so I'm going to multiply all this by 4a squared. Okay, in doing so, I'm going to end up with the a squareds cancel out. I get 4 times, I'll do a different color here. I'm going to get 4 times 7.5 squared works out to be 56.25 minus 9 times 9, and the 4a squareds cancel out. I get 1 times 4a squared, so I get 4a squared like this. So I'm going to solve for the a squared. I need to multiply this out, so I get 225 minus 81 equals 4a squared. That works out to be 144 is equal to 4a squared. Solving for a, so 144 divided by 4 works out to be 36 is equal to a squared. That makes a plus minus 6. Well, a can only be positive, so we just say that a is positive 6. Once we solve for a, we can solve for b by plugging into that original equation. 2 times a over 3 equals b. Okay, so that was from this equation here. It's just plugging back into that one over there, plugging the value of a that we solved for, calculating b. B is equal to 4. So I get a is 6 and b is 4. So once I've done that, I've established that it's a plus 1. I solve for a and b, so I now have the equation of that hyperbola. It's x squared over 36 minus y squared over 16 is equal to positive 1. That is that equation of that hyperbola.